selecting significant climate anomalies. Is that where you want to start?
Yeah, we haven't done this before, but yeah, that would be a cool place to start because you were on the map. It says, what is April on record for Nome? Well, you're not in Nome. I'm saying that wrong. But yeah, what is April on record in a part of Alaska? All right.
But
Salt Lake
the
City.
point is taken because even the interior was pretty wet, which is for April. April is supposed to be, or historically, is the driest month of the year in interior Alaska.
Oh no, here we go. And it's not now. Oh gosh.
This past April was not. Now, of course, one point does not make a trend, but still.
Right. Yeah, but there's all these records being broken all the time, like every month it seems. There's what Salt Lake City had its driest April on record, warmest April on record for parts of Hawaii. All these things going on across the country.
Looking at the latest projections for temperatures, it looks like the Canadian Shield going all the way south deep into like towards Arkansas, that area is going to be perhaps right at average or a little below average temperature-wise for the upcoming summer months. But when you look at the two coasts, it's going to be warmer than usual.
Oh no!
It's almost like a U shape around, U shape of warmth around the, whatever central, normal or cool location. But when you look at from Canada across Scandinavia, it's cool. It's going to be cooler than usual. And then you go on the other side, back to the bipolar polar.
Right.
The Eurasia and Siberia are cooking.
Oh my God, I know. And I saw something from Zach Labigan, and it's the red blob has gone into the middle in the North Pole. It's over the water now. It keeps shifting towards the middle of the North Pole. It's not good. I know summer's around the corner, but it's not looking good.
Well, that's reflecting how the high pressure systems are moving about.
Oh, okay. Do you want to expand on that real quick?
What's that?
Do you want to expand on that real quick?
What do you mean?
Well, the high pressure systems, they're meandering.
High pressure systems are never static.
Right.
They're going to move around by rotation of the planet, jet streams. What we also call topographic steering. I won't get into that. That's crazy fluid dynamics. But there's also vorticity factors. Vorticity is basically a measure of spin. A good way to think of vorticity is watch a figure skater when they go into a spin. Right there, when their arms are out, they're spinning slow. And then as they bring their arms in, they spin faster.
Okay, interesting.
That's just a way to envision vorticity, because you have rotating systems, be it in the ocean or in the atmosphere. And if you look at the depth of the column, the longer it is, the deeper it is, you actually find that the radius is smaller, so they tend to spin faster. Whereas if it's so it flattens out, squishes out, then it spreads the diameter of the system, and then it slows down. And lots of times this will happen as it goes over mountains into a valley, or in the open ocean, over a sea mount or not, that kind of stuff. It's very complicated fluid dynamics. So.
No, it's good. The example you gave with the ice figure skaters was a great one. That has nothing to do with, going back to the mean temperature departures from average, the entire United States. Does that have anything to do with what's going on with Montana and North Dakota and South Dakota? It's like below average. I mean, the polar vortex is dipping again, or
it's a contributing factor for sure.
Okay. Most of the state. Sorry, go ahead.
It is a contributing factor, and that, of course, is tied into what the Arctic dipole is doing, along with the Arctic oscillation, more like the Arctic oscillation. So it's tied into that for sure, and how it affects the jet stream, etc. But the interesting thing is that because of the warming, because of the less strong gradient, be it in pressure and or temperature, is what allows the jet streams to start dipping.
Yeah. And they're
We
dipping.
had a very strong gradient this past winter, so the polar vortex was very tight.
Mm-hmm.
So we were cooler up here at high latitudes. Lower latitudes, we're not.
Mm-hmm.
Now that has weakened,
Right.
so now the cooler air spills down.
Okay, because there's not much going on with this graph in terms of April. I mean, there's a little bit, it's still coming out of winter. You're starting to be spring. It's spring, basically, right? April. And then, it's basically white. Everything's normal, I guess, or average is the right term. But there's a little bit of spots of red, not too red. So I don't know what's going on with April as a singular month. It seems average, even though I guess in the United States, but around the world it was the hottest April on record, or the second hottest. Yeah.
It's tied into the NAO and the AO, and just the physical conditions.
Okay.
So from a meteorological point of view, this was ho hum.
Yeah, well, going to the precipitation percent on average, and juxtaposing the two at the beginning of this climate report, I don't know. I mean, the precipitation, you could see Montana is dry there, but it's colder. That's interesting. It's wetter in Southern California. I mean, the precipitation is very dry in West Texas and the bottom of New Mexico. And you can see like the red splotches in the Southwest on the other graphic. But
well, remember that cooler air holds less moisture.
Oh, and
so if you have cooler temperatures, less moisture, you're going to most likely have less precipitation. Now,
interesting.
Yes, warmer air can hold more moisture, which can lead to more precipitation, but it's kind of double-edged, because if you're over, say, a arid region, then you're not going to really be able to put much moisture. Even though the air has the capability to hold more moisture, you're not going to be able to necessarily, because when you have when you have warmer air and it's over, say, non-arid region, take Alaska, for example, with all the snow melt. The ground is wet, but the air is warmer and dry, so it sucks the moisture out of the ground.
Oh, interesting.
And it goes into the atmosphere, which means, and even with all the snow that we had, some of the fires that was smoldering from last summer over winter have flared up.
Really? Oh no.
Really. So this is why you hear that thing that, dry areas become drier, wet areas become wetter, because the dry areas have already, even though the warmer air can hold more moisture, there is no moisture to pull out of the ground. Whereas the wet areas, there's moisture, you have a warmer temperature, it can pull more moisture out.
Does that play into what's happening with Florida? I mean, Florida's different, right? It's tropical, at least at the bottom of Miami, but in the graph it's red but it's wet. But that's different. That's a little different. I don't know.
It would tie in, because don't forget, if you take a place like Florida, I mean, it's surrounded basically by ocean, so it's going to be a humid, wet area versus, say, Utah.
Exactly. I mean, well, when they get warm, I guess maybe that's more moisture there, but it's different in different like ecosystems and biomes and climates and stuff.
What's the old saying? It's hot there, but it's a dry heat.
Oh yeah, that's like Arizona, right? It's hot.
Hot anyway.
At least it's a dry heat. I think that's what they say. Oh my gosh. So just getting us forward, I mean, the statewide average temperature ranks, no record warmest for any state in April. No record was broken. However, once again, Florida keeps coming up. It says, well, the second bullet point says above average temperatures were observed across much of the West Coast and Southwest, as well as portions of the Gulf Coast, not good for the hurricane season, and Florida. Florida ranks 6th warmest on record for April, and then it's talking about Miami. It's warmest April on record. Yeah, so Florida's having a really record warm year.
Yeah, it's
It was
not a
much
place
above
that
average.
not a place I'd ever want to be, but
Yeah, well, because you'll have the hurricanes coming, and if
well,
Florida keeps
there's
heating
that.
up, it's going to soak up that energy, and it's going to produce bigger storms. Correct? I mean, that's the risk of living in
Exactly.
Florida.
Exactly. Storm's gonna get really snotty.
Yeah, and there was one the other week, I think, already starting. So the hurricane season started early, and it's like these East Coast states are just. Then you have the compounding issue with COVID this year, so that's going to be not good for the Eastern United States. Compounding issues with COVID, and then you have climate change. So things are just they're rolling in together. We're mixing disasters at this point. Yeah, so Florida is having a record warmest year so far. If you go to the year-to-date highlights a little bit down, it shows the first 4 months, and then everything, all the data so far we've talked about combined. Florida's having its record warmest year so far on record. Okay. It's pretty intense, and much of the 48 states are above average for this entire year so far. I know there's debate whether 2020 will be the hottest year on record, but we'll see.
That's going to be interesting now with now the reduction in fossil fuel emissions is 17% now
Oh,
due
wow.
to because of the the virus and the shutdowns and stuff like that. It's going to be interesting to see how this all plays out.
And we'll be tracking it.
Yeah, we'll be tracking it.
Yeah, we'll see. I mean, this is kind of an interesting time period for scientists, at least climate scientists and oceanographers and such. So things are changing, but then you throw this into the mix. We'll see.
We'll
The COVID
see.
situation.
I don't know if we'll get to this later, but did I send out that tweet basically saying that, yeah, and this is something that I said, and I do remember sending this out, that there is definitely a neutral ENSO situation being set up.
Okay, yeah, I have it. It's from Philip Klotzbach. Sorry
So
if I said.
something, yeah. But I mean, we can get to that later. But it's basically so when
Okay.
you throw in what the ENSO is doing, ENSO greatly affects what happens in North America. It really does.
Okay.
But it affects the whole planet, but it seems to really affect what goes on in North America. And plus, then you start having the teleconnections, and so with the mid-Atlantic oscillation and all that kind of stuff there, with the Atlantic, the AMO. So all these systems greatly affect what's going on. It's then when you put in the human effects that then start affecting those systems is when we start getting the changing climate situation.
Correct. Well said. I mean, we can go over this graph now. I think it fits perfectly right what we're talking about because, what will happen for the rest of the year. We talked about possibly there being a La Nina, and then it kind of switched or became neutral, correct? That was.
Yeah, I mean, it was shaping up one way, and then I was the one that basically said, "Hey, this is going to." I think last one or two times I spoke, I basically said, my opinion is that it's going to turn into a neutral, and it looks like that's what the situation is. So, latest ENSO prediction. Yep, with you got the graph with all the pretty colored lines on it.
Right. Yeah. You always have the good graphs. Thank you. Yeah,
Now,
we're looking at
just
the.
okay, so you have the SST anomaly. Okay, so this graph is not necessarily showing a calculated value for the index per se, which looks at temperature, wind forcing, atmospheric pressure, sea surface temperature. It's a whole bunch of parameters that are taken into account. Usually when you calculate the ENSO index, anything that's between the 0.5s, from minus 0.5 to 0.5 is considered to be neutral.
Oh, okay. That's good to
So when you
know.
get above, say 0.5 to like say, 1, then that's a mild El Nino, minus 0.5 to minus 1, a mild La Nina, and anything above 1 or less than minus 1, then you have a strong, respective El Nino or La Nina. So when you look at the index, the actual calculated index value, anything between the 0.5s is considered to be in the neutral situation.
Okay, that's
And
very
that's
interesting.
basically what we have here. In fact, looking at this graph, you have to pull this up so I'm bloody nearsighted. But
Dang it.
so, okay, latest ENSO prediction influence now. The majority of statistical and dynamical models call for ENSO neutral conditions for peak of the Atlantic hurricane season. Dynamical models generally have cooler forecasts than statistical models. Okay, and so what they're showing is the data from various collecting agencies, but you can see how it's pretty much between the 0.5s.
Right, it's in the neutral zone.
It's a neutral. Throw the stick shift into neutral and coast.
How interesting. So wait, the +1 is El Nino and the -1 is a strong La Nina. The La Nina is negative.
Usually, it depends on who does the calculations, but usually, if
Oh,
you have positive values are El Ninos, negative values are La Ninas. So
okay, and yeah,
So
that
when you get
changes.
above, so you get 1 or above, then you're, or if you get between 0.5 and 1, that's a mild El Nino. More than 1, you start getting to moderate to on up to strong El Ninos. Minus 0.5 to -1, a mild La Nina. -1 or further, moderate to strong La Nina, usually. It's
And
on the
these two
scale.
systems, right, they come and go. I don't know if they change each season or do they take like 5 years for the El Nino or do they switch? Is it very like, does it vary year to year or is there stretches?
The ENSO cycles on 6 to 18 months.
Okay. Okay,
So
it's short.
it cycles between that. Now, when
Interesting.
you get the strong ones, that can be on a 7-year cycle.
Okay, but it might fluctuate year to year, but it's still strong.
So you might get, mild this, neutral, this kind of, and then also, ooh, now we have a strong whatever, El Nino or La Nina. So that is like a 7-year cycle, but the system itself is a 6 to 18 month cycle
Oh,
on
okay.
average.
Good to know. I didn't know.
Yeah, it's a lot more frequent than say the PDO, which is about 20 to 30 years.
So all these cycles, right, are being disrupted somewhat because of the human interference into the climate.
Yes, we are altering what takes place.
And there's
And
really no more pattern, right? That's the issue. Go ahead.
sometimes there isn't, or the pattern is, well, let's put it this way. Of course, now with improved computing models and software and so forth, we're able to better tease out which is the natural signal, which is the anthropogenic signals. We're able to better, and so when scientists say, well, humans are accounting for this percentage of what we observe, that's because it's been calculated.
Okay. Good to know.
So, for example, when you do, let's start with a general linear model. Okay, so you have the dependent variable is equal to some intercept plus a coefficient times the x variable. Okay, how well does this model explain what has been observed? All right, you might see an R square of 0.52. Not a great model. In fact, pretty poor model. But if you have an R square of 0.88, okay, that means this model is explaining 88% of the variability in the responses. Okay? So, and values of R squared range from 0 to 1. 0 basically means this is complete total shit. You don't have anything here. Move on. 1 means that basically every single data point falls exactly on the line.